welcome class. You're all welcome once again. In our previous class, I gave you some revision questions to solve, but most of you couldn't solve it. Most of you, in fact, all of you could not solve it. Nobody attempted it. So I decided to solve them today. Let me solve the questions and then we move on from there. All right. The first question there is, what is the range of values of C for which the line y equal to 2x plus c is to meet the curve x squared plus 2y squared equals to 8 in two distinct points? So what we mean by two distinct points, and if a line, the first idea, if a line is to meet a curve, now for instance, if I have a line here, this is a line, and the curve would meet it at two distinct points, then it is like this. See? But the first thing you should know, if a curve is to meet a line, then they combine to produce real roots. Don't forget this. The moment a curve and a line meet, then they produce real roots. Okay? The only time they will not produce real roots is when they don't meet. So when they meet, they produce real roots. Okay? All right. If they are at two distinct points, okay, then the roots will be different. All right, good. So for real roots, solution now. For real roots, we should know that d is greater than or equal to 0. Okay, d is greater than or equal to 0. This is the condition for real roots. This is the condition for real roots. So now, I'm going to now solve the two equations simultaneously. Okay, the two curves, the line and the curve, I'm going to solve them simultaneously now. Let me draw a straight line here. All right, I'll take the first line as equation 1, y equal to 2x plus c. Call this equation 1, and then call the other one x squared plus 2y squared equal to 8. Call it equation 2, right? All right. In solving simultaneously, I can put 1 in 2. Put 1 in 2 because y is already the subject of the formula in 1, right? Y is already the subject of the formula in 1. So I will say put 1 in 2. See? That means that anywhere there is y, I replace it by this. So I will have x squared plus 2 bracket what now? 2 bracket 2x plus c squared. This would be equal to 8, right? Now I have this equation in terms of x only, right? C is a constant, right? So we'll have to expand this or open the bracket to give us x squared plus 2 bracket. I taught you how to open the bracket like this. So we're going to have 4x squared plus 4xc plus c squared is equal to 8. That is it. Now, this becomes x squared plus 8x squared plus 8xc plus 2c squared equal to 8. I can now put it in the standard quadratic form. This becomes x squared plus 8x squared becomes 9x squared. Then this is the only term in x. I will leave it there, plus 8xc. Then the constant terms are this and this. I put them together. 2c squared minus 8 is equal to 0. That's it. I have it now in a standard quadratic form. Here we have our a is 9. B is 8c. C is 2c squared minus 8. These are the parameters, right? All right. We can now plug this into this expression. Where is it? For d greater than or equal to 0. This is for real roots. Okay. Now we can have, therefore, d greater than or equal to 0, right? It implies that b squared minus 4ac is greater than or equal to 0, because d is actually b squared minus 4ac. We call it the discriminant, if you remember. So now I can have I'll plug this into this. Okay, I'll plug them into it. So what's my b? My b is 8c. I plug it in. We have 8c squared, all right, minus 4 bracket. What is my a? 9. Then what is my c? My c is 2c squared minus 8. 2c squared minus 8 greater than or equal to 0. This is what we have. Okay, the next thing is square this, simplify everything. We have 64c squared minus, this is 36. I'll open this bracket. 4 times 9 is 36 times 2, 72. 72c squared. Then minus and minus will become plus here. We have 36 times 8 is 144. 36 times 8, right? 36 times 8. 288. 288, right? 144 times 2 actually. All right? Greater than or equal to 0. All right. Here we have 64. 64c squared minus 72c squared. Right? 64c squared, 64 minus 72 will give us what? 8. So we can have minus 8c squared here plus 288 greater than or equal to 0. So this is actually 288 minus 8c squared greater than or equal to 0. Right? Okay, what's the next thing to do? Let me see. Can 8 go into 288? Yeah, it can go. Can 8 go into 288? Yes. Let me just cancel out, right? So let me divide through by 8. So we're going to have 36. It should be 36 minus c squared greater than or equal to 0, right? All right. That's it. But this can be written as c squared minus 36 less than or equal to 0. Okay, how did I get this? How? By multiplying both sides by a negative number, by minus 1. If I multiply both sides by minus 1, this becomes negative, this becomes positive, right? And then this is 0, it's still 0, right? But then the effect of multiplying both sides by a negative number, it reverses the inequality. Remember that? And that's it. So now we can have this. But I can write this as this. C minus 6 bracket C plus 6. I have factorized this. So it's still less than or equal to 0. Okay? All right. How do we deal with this inequality? This is an inequality. I want you to notice one thing. That this is an inequality less than. Okay? Quadratic inequality with a less than like this. Just solve it first. After solving it, you now set C is equal to 6 or minus 6. If you solve it, this is what you're going to have, assuming it was just an equation, right? But this is an inequality carrying less than. For this carrying less than, all you have to do is to get the values of C first. After getting them, that means that you can now write this as, therefore, which one is the smallest value? The smaller value here, sorry. Which one is the smaller value? Is minus 6. See, minus 6 is less than. You write it now like this. Minus 6 is less than what? C. Less than 6. That's your solution. This is the range of values for which that expression. So that means we have minus 6 is here, and here we have what? Plus 6. Okay. Okay. What is the range of values of C for which the line this is to meet the curve face in two distinct points? These are the range of values of C. Like this and like this. All right. Thank you.